5.3 is about solving linear equations using the elimination method. So we talked about graphing, we talked about substitution. This is my favorite method because most of the time it is the most efficient and you get to cross things off, and I love crossing things off. So what does it mean to eliminate something? When I hear that word, I think about video games or spy movies where someone needs to be eliminated. It means to get rid of something, and that's exactly what we're going to do in this method. We are going to eliminate or get rid of a specific variable. So let's talk about how do we do this. The very first thing that you're going to want to do when you're solving using elimination is have your variables stacked so that your x variables line up, your y variables line up, and your constants line up. And typically this is going to be by the equations either already being in standard form or you putting them in standard form. That's going to be the most common way you're going to see this. However, if you look at number 3, those equations are both in slope-intercept form, but they are also, the variables are lined up. The y's are lined up, the x's are lined up, etc. So step 1 is to make sure that the variables are lined up. Step 2 is to multiply one or both equations together to eliminate a variable. So you're asking yourself, if I added these two equations together, which variable would go away? And how do I multiply by something to make that variable go away? Step 3, you're going to then solve the remaining equation, which is going to be a one variable equation, just like we did in 5.2. And then you're going to plug that variable back in to find the other variable and make sure we write our answers as an ordered pair and check, at least mentally checking to make sure we're doing this correctly. So let's go ahead and look at the first example. X and Y are already lined up in the first example. So what I'm asking myself and what I want you to ask yourself is, what number could I put in this little red box that I'm drawing? What number, if I put it in that little red box, would make it so that if I added these two equations together, my x terms would add to be 0? What number, if I put in that little red box, would make it so that my x terms would add to be 0? And that number is 3. You could also ask yourself, if you didn't want to work with x, if I put a little box here, what number could I put in this box so that if I add my y's together, I would get 0? And that number would be -2. Well, we know that in math, I can't just put numbers where I want to because I feel like it. I have to actually do something that I'm mathematically allowed to do, like use the multiplication property of addition. So let's eliminate x. I'm going to multiply everything in this first equation by 3. And remember, you have to multiply every single term by 3 in order for this to still be mathematically true. So that's going to give me 3x plus 6y equals 33. Now what I'm going to do is I'm just going to add these two equations together. So 3x and -3x is 0. Eliminate. That's why I like this method. I like making those sound effects. Y plus 6y is going to be 7y. -5 plus 33 is going to be 28. And then y is going to be 4. Now remember, we just found half of our solution. We need to find the other half, and we can find that by plugging y in. So I'm going to circle this first equation. X plus 2 times 4 equals 11. So what plus 8 is 11? X is going to be 3. And there I have my point. So if we look at number 2, we're going to start by asking ourselves the first question, is everything lined up? Yes, everything is lined up. The second question we're going to ask ourselves is, how could I eliminate a variable? So thinking through this, there's a couple ways I could eliminate a variable. If I had a -3 in front of this x, then my x's would eliminate. So one of my options is I could multiply this whole equation by -3. But I also noticed that if I add these two equations together as they are right now, these y terms are already going to add to be 0. So why multiply when I don't have to? So I actually am going to just start by adding these two equations together. So 3x plus x is going to give me 4x. -4y and +4y is 0. The sound effects really do help. 10 plus -2 is 8. So this is going to give me that x is equal to 2. So I found my x value. Now I need to find my y value. I'm going to plug that into this second equation. So x, which is 2, plus 4y equals -2. I'm going to subtract 2 on both sides, so 4y equals -4, so y equals -1. And I have my ordered pair. Remember, you can always plug this ordered pair back into both equations and make sure that your answer is right. That gives you the ability to be really confident when you're submitting your homework, when you're submitting quizzes, and so forth. You can always check your answer. Okay, number 3, they are not in standard form. However, the variables are still lined up. So what number could go in front of my y so that when I add my y's together, I get 0? Just a negative sign. Or what number could go in front of my x's to make the x's add to be 0? I could use a -3 in this bottom equation. So I'm going to just multiply the top equation by -1. So that's going to become -y equals -3x. And then I'm just going to add those two equations together. So y and -y is 0 equals x minus 3x, or x plus -3x, is -2x minus 2. So 2x equals -2, so x is going to be -1. And I can plug that into this top equation. Y equals 3 times x, so y equals 3 times -1, which is going to be -3. So make sure your variables are stacked, multiply as needed so that when you add the equations together you can eliminate a variable, and then solve. Don't forget to solve for your other variable afterwards, and write your final answer as an ordered pair. Why don't you try the 2 examples on the next page? Don't do the word problem, just pause the video and work through examples 4 and 5. All right, when I look at number 4, I think that to eliminate the x's, I could multiply the entire top equation by +2. So that would give me -14x minus 4y equals 2 times 0 is 0. And then now I'm going to add those equations together. So my x's are going to go away. I'm going to get 3y equals 0, which means that y is equal to 0. So I found half of my answer here. I'm going to plug y equals 0 into the second equation because I already crossed off something in my first equation. I can't read it. So that's going to give me 14x plus 0 equals 0. So x is also going to be 0. So 0, 0 is the ordered pair that I am going to get as the solution to this system, which remember means that these two lines cross at the origin, at the point 0, 0. And this kind of looks like a smiley face. Let's make it a smiley face. Okay, number 5 looks a little tricky. When I first look at it, there's not one number that I can multiply one equation by to eliminate a variable. So that means that I'm going to have to do a little bit more work. So I'm going to solve for y first. So I'm looking at these two y's, -2y and +3y, and I want to make them both something to make this become 0. So I'm going to multiply the top equation by 3. And when I do that, I'm going to go up here so I have more space. That's going to give me -9x minus 6y equals 3. So I took the top equation, I multiplied every term in the top equation by +3. Now, I have a 6 here, so I need to multiply the bottom equation to make sure that this y term, again, has a 6. That's going to give me, I'm going to multiply everything by 2, so 10x plus 6y equals 10. And then I'm going to add these equations together. -9x and +10x makes just x. My y's are going to add to be 0. X is going to equal 13. Now that I have x, I can use any of these 4 equations, the first 2 or the new 2, to find my y value. So I want to use the smallest numbers and the fewest negative signs. So I'm going to take this equation in green. 5 times the x I just found plus 3y equals 5. This is going to give me 65 plus 3y equals 5. That's going to give me that 3y equals -60, so y is going to be -20. So I have the ordered pair 13, -20. Oh my goodness, a word problem. We all need to freak out right now. But you know what I did? I made this word problem so short that it doesn't even look scary. It looks like it's only one sentence. It's more than one sentence, but it's nice and short. So let's read through it together. James has 11 coins. All of his coins are quarters and dimes. He has $1.85 total. How many of each coin does he have? So the very first thing I'm going to do is define my variables. I'm going to let Q equal the number of quarters. And I'm going to let D equal the number of dimes. Now I'm going to read through each sentence. James has 11 coins. So that means that the number of quarters plus the number of dimes equals 11. I'm going to call this my totals equation. This is how many of each he has. However many quarters plus however many dimes. So the nice thing here is he could have 1 quarter and 10 dimes. He could have 0 quarters and 11 dimes. He could have 5 and 6 or 8 and 3, right? You can kind of see the options for the possible solutions here. Now I'm going to look at the second sentence. He has $1.85 total. So what do we know about quarters and dimes? We know that quarters are 25 cents. So money-wise, if I had 4 quarters and I multiplied that by 25, I'd have $1. So I could multiply 0.25 times Q to figure out how much money I have from quarters. Similarly, dimes are 10 cents. And this is going to equal $1.85. And what I'm actually going to do is I'm just going to move the decimal place twice on every single one of these so I don't have to work with decimals. I hate decimals like you hate fractions. So if I multiply everything in this whole equation by 100, what I get is 25Q plus 10D equals 185. And even though 185 is a big number, I still like that big number a lot better than I like dealing with those yucky decimals. So now this problem could be easily solved using substitution or elimination. You could subtract D on both sides and use substitution, or subtract Q on both sides of the red equation and use substitution. But I love elimination, and this whole section is about elimination. So I'm going to multiply everything in the top equation by negative 10. So negative 10Q minus 10D equals negative 110. That's going to give me 15Q equals 185 minus 110, 75, which means that Q is going to equal 5. So he has 5 quarters. If James has 5 quarters, how many dimes does he have? Well, there are 11 total coins, so he has 5 quarters and 6 dimes. So when we are using elimination, the most important things from this section, make sure your variables are lined up. Eliminate the variable that is more easily eliminated. So eliminate by multiplying one or both equations by something so that when you add them together, one of your terms goes away. Solve the remaining term, and just like in all of the other sections in this unit, plug that variable back in to find the other and write your final answer as an ordered pair. Looking forward to working with you on this in class. Thanks for listening.